Howdy class. It's about 4:10 right now, so I'll probably have this posted about 5 o'clock for those of you that aren't going to watch it. And I guess that doesn't matter. But we're going over the quadratic formula in class today. I'm not going to be here, but Miss Page is going to go over your worksheet and the proof with you. So I stated here that I have a proof in class. It specifically says we need to show you the proof of the quadratic formula, so we're going to show it to you. But this is what the quadratic formula's equation looks like. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a lot to take in. But this is all stuff that you've seen before. It's just your a, b, and your c of your quadratic equation. So what this formula or equation allows us to do, it solves any quadratic equation for x. That means that no matter what, this method will work for anything. Okay? So let's go ahead and get the second board up. So here's just an example of using it to solve our equation. So we have an equation here, x squared plus 4x plus 3 equal to 0. So my a is 1, my b negative 4, and my c is 3. So this is what my equation falls out to be. It's negative b, or negative 4, plus or minus the square root of b squared, which is negative 4, minus 4 times a, which is 1, and c, which is 3. And that's all over 2 times a. My a in this case is just 1. So I just need to multiply basically all of this out. Multiply negative 4 by negative makes positive. Plus or minus negative 4 squared is 16. And then 4 times a times c, that just leaves me with negative 12. And then all over 2a is just 2. So then I just simplify down from here. I have the x equals 4 plus or minus the square root of 4 all over 2. And then down here, I just, square root of 4 is 2. Work my way down, dividing 2 into each of these. That gives me x equals 2 plus or minus 1, which means x equal to 3 and x equals to 1 are my solutions to this equation. So this is a foolproof method. It works, like I said, for everything. And there's an important part we need to talk about. It's what you see here under the square root. It's called the discriminant. So, question is, what is the discriminant? It's just the part under the square root of the equation, like I said. And what does it tell us? It tells us a lot, actually. If the discriminant is greater than 0, we have 2 real roots of our equation. We'll get into what that is in a second. If the discriminant is equal to 0, we just have 1 real root. And then if the discriminant is less than 0, we have no real roots. And I just added this little aside here. They're actually 2 imaginary roots. Now next week we're going to talk about what imaginary means, but for now we'll leave that until next week. So let's go over an example of what the discriminant is and how to use it. So if I have this equation right here, x squared plus 8x plus 16 equals 0, this is my discriminant. And how I'm getting that is I'm looking back at my formula for the quadratic equation, and it gives me b squared minus 4ac. That's what my discriminant is, just everything under the square root. So in this case, that's 8 squared minus 4 times 1 times 16. All this simplifies down to 64 minus 64 equals 0. So we can say that I have 1 real root, given my rules of what I'm getting out here. So I need to make a quick note before you guys have class tomorrow, and that's if we're solving real-world problems. If my discriminant shows that I have no real roots, then in the real world situation, I have no real solutions. So that's no solution at all. So again, if you're solving a real world equation and your discriminant shows that you have no real roots, then in real world terms, you don't have a solution at all. I'll see you guys next Monday. You'll have a quiz, I guess, the middle of next week, and then we'll review for your unit test over all of the quadratic equations. I'll see you guys next week, and you guys have a great weekend.